Welcome, everybody. Welcome back to another very exciting month of demystifying post-production. And this month, our topic is Essential Motion Graphics Week 1. All right, I have a few guests here, and one of the guests is our main presenter for today. It's Lionel Vicidomini. You already know him.
Hello.
And we also have Dustin Valkema here, and he's gonna, yeah, help answering questions and so on. So yeah, let's take care of the housekeeping. And the first thing we always do is we go to maxon.net/events to make you aware of all of the interesting webinars that we are doing. And if you scroll down here, you can already see, well, we have this Essential Motion Graphics series that we are running this month. We also have Ask the Trainer this Thursday with Thanasis and myself going through a few certification topics. So the topic for the next one is going to be rigging fundamentals. Every Friday, we have VFX and Chill, and we also have a hands-on workshop running at the moment about Redshift. So Ellie is going to take you through the basics of Redshift and is going to do some really cool stuff together with you if you want to follow along. And then next week on Thursday, we have the second episode of Maxon Color. Great. So whenever you miss like one of the webinars and you want to rewatch them, you can do that on the Maxon Training Team YouTube channel. Here we host all of the sessions that we are doing and a little bit more like quick tips and so on. All right, so another thing I want to point out because it's more and more relevant is our certification site. If you go to maxon.net/certification, you can see those different sorts of tests that you can take. And one interesting one is the elementary knowledge test that you can take for all of our products, except for ZBrush at the moment. Also in multiple languages, of course. And this is a free test that you can just take. It's like just a multiple choice test, and you have to answer a few questions. And then there is the Cinema 4D Basics Comprehensive Certification Test, which is a certification for pro users, more or less. And in here, you can find a list of certification topics. And if I click that, you can find a whole list of stuff that you should know if you want to become certified. But the other thing, or the other point why I'm showing you this, is that Thanasis and myself, we are going to go through that list in the next Ask the Trainer sessions and always pick one of the topics and show you some stuff that you need to know as some, let's call it some sort of certification preparation or like some level of stuff that you need to, stuff that you need to know if you want to become certified. But even if you don't want to become certified, it's very interesting. So the last thing I want to tell you already is that we are always happy to help you with t-shirts. So we want to give away free t-shirts, and in the GoToWebinar interface here, you can see a handout section, and in there, there's a PDF document, and in there you can find a coupon code. And if you type in that link to the merch store that you also find in that handout, you will get to this page. First of all, you have to type in the coupon code that you can also find in there, and then you get here and you can order one t-shirt. You will get it for free. You will only have to pay for the shipping. And that's already all of the housekeeping. So the topic for this month is, maybe all of you have seen the holiday animation that has been created by Lionel and a few friends of Lionel. And we're going to break down some of the scenes that you can see in here. And today, Lionel is going to show you how you can create a rolling cube, which is a pretty interesting thing. So, Lionel, I guess you just take over and get it rolling. I'm going to throw the screen at you. Here you go.
Okay, so can you see it?
Yes.
Yep, it's there.
Perfect.
All right, perfect. Okay, yes, so yeah, we're going to talk about a rolling cube and how to make a cube roll, and that's more difficult than it seems. In the greeting cards video I shot for Maxon, there was this sequence. We have this rolling cube rolling away, and then we can find it here on the Penrose Triangle. So it's very short, but it's important because we can see the cube at some other time. And how did I do that? So, well, there is several ways to do it, many ways, but I wanted to show you that you can do it with capsules and with nodes inside C4D. First, let me show you how it works here. This is one of the final solution I used here. This is a node, and as you can see here, we have a progress. We have our cube rolling onto a spline. We can change the size of the cube, and it's going to follow along, roll perfectly. And of course, we can change the spline to whichever one we want. So if I change here to a circle, and then I'm going here on my node to put it there, it's going to roll on that circle. So it looks simple, but it really isn't. All right, so let's start. Let's see first what is the problem if you just create a cube and if you want to roll it. Well, let's make it 50 centimeter. Well, it's very obvious if I just rotate it on this axis. So let's create a few keyframe for 1 second. And I'm going to rotate it 2 times, so 180 degrees. Let's go back. So it's rolling. Oh, forgot to enter the keyframe. So let's use the auto keyframe, it'll be easier. Okay, so it's rotating. And if I move it on the x-axis, so let's go back here to 0, 25 frame. Let's go this way, for example. Okay, so now it's not rolling. It's rolling onto itself, but it's not rolling on the ground. If I just put a ground here, a plane, let's move it down. Let's show also, I'm going to hide the work plane and NA to C. We can see here, yeah, it's going into the ground. It doesn't work. Okay, so it's obvious. It should roll onto its edge here, then land on this face, then roll onto the other edge, and so on and so on. How can we automate that? There is many ways, like I told you before, and among the several ways, I'm going to show you how to do it with Capsule. Maybe the easiest way, the simplest way would be to do it with only keyframes. If you move your anchor point and keyframe, it's manageable, but it's difficult. It's going to take a long time. With Capsule, it's going to be easier, and with nodes, it's going to be even easier and more parametric. Okay, so first, let me show you. This is the one example with Capsule. So we have a rolling cube following a ramp. And what's nice here again is that I can change the size of my cube. So I need to go there actually. It's in the user there. And you see it's going to follow. And also I can change my ramp. So this is here called circle. let's go to point. And if I take this point and move it down, for example, it's going to still work. If you had to keyframe that by hand, that would be a nightmare. And the trick here is to use the geometry axis, which is a capsule, and then there is some XPresso. It's very simple, I promise you. Okay, so let's start. I'm going to create a new scene. Let's create a cube. I'm going to change my cube to the default cube. Actually, this is my default cube, which is a 3x3. This is a feature of R25. I'm going to change to the default one, so there is only one segment. And we're going to change to 50, 50, 50 centimeter. Okay, then let's hide the work plane again. So I want to move it on the x-axis. If we look at the asset browser, we do have in the capsule. So here you can find in notes. If I can show you from there. It's a geometry modifier. And I'm going to change like that. It's the geometry axis. So all of the modifier you can have in those category here can be used as capsule, meaning that you can put them inside the object manager and use them. They're using nodes, the node system inside Cinema 4D, but make it easy to use with the object manager. So one of them in the geometry modifier is the geometry axis. You'll understand very quickly what it does. If I put the geometry axis now and change the geometry axis, we're going to see our cube change along its axis. The geometry is going to move, but the axis is not going to move. Okay, so this way you can have it on the ground. Now, if I take my cube and change the size, the Y size, for example, I can do that, which is already very interesting because by default, it just scale from the center. Here, it's going to scale from the bottom. And we're going to use it another way so that it's going to rotate along its base. Okay, so here, there's a trick. We're going to unplug here the geometry axis. I'm going to put the cube inside a connect object. This is the trick. Actually, the connect object is a very, very useful, very powerful object we can use. We use all the time because it's going to solve a lot of problems. I'm not going to explain how it works already, but you can almost imagine it as solution for all is going to contract to connect all geometry into one and make several objects look at the one. So here, if I put my connect and then the geometry axis inside this hierarchy, so whichever order, it doesn't matter. We can see the geometry axis is working. And now, if I take my cube and I'm going to change some axis, this one, for example, we can see something very interesting. It's going to rotate along its base. So let's go here. It'll be more obvious. And you can see it's rotating from its edges. Then it's going to fall on the bottom, and then again rotate on the axis. That's very useful. That's exactly what we want to do. So let's go back here. So now the idea is just how to automate so that when I move my cube with the connect this way, it's going to rotate along this axis. Okay, so I could do it by keyframe, but I'm not going to do it. I mean, that would be too easy. We're going to use XPresso for that. So XPresso, I'm going to the connect object, right click, and let's go to programming tags, XPresso. Okay, so this is my XPresso editor. I'm going to dock it right here, so I can use it all the time. I don't need to see very much my cube. Okay, so I want to move, when I move my cube from left to right, I want it to rotate automatically. So I need to plug, to put the connect object inside the hierarchy, XPresso hierarchy. So this is the connect. And the element I want to plug, I want to control is the x-axis because I want to move it on the x-axis. Okay, and this is going to be the driver. This is going to be the parameter that's going to drive the rotation of the cube. So I'm going to take here the x, and you can just slide it here. Now we have our position x. Okay, now I wanted to move the cube on this banking axis. Okay, so I need to drag the cube here, and then I'm going to take the banking and put it on the blue. Okay, so red is going to blue. Red is going to control blue. So if I plug it right away, it's kind of going to work, but not really. If I take my connect object and move it, you can see there is something funky happening. It's like it's rotating, but much too fast. There's something wrong. It works, but badly. That's not exactly what we want. So let's go back to the origin. It's rotating too fast. Easy to understand. So we need to convert this unit in centimeter to something that can be understood here, which is the rotation. So we have for that a node, which is very, very powerful, which is the range mapper. And that's interesting because when we'll do some real nodes inside C4D, the real nodes, you'll see it's more or less the same thing with the same name, a little bit different. So the range mapper is one of them, which is exactly the same. So I'm going to put it here in input, output. Okay, and now the range mapper is going to do some mapping. So it's going to take the value input lower upper, 0 to 1, translate it to 0 to 1, meaning that it's not going to do anything right now. Okay. Now, if we think about our cube is 50 centimeter. Okay, so when it moves here by 50 centimeter, it should roll exactly 90 degrees. Okay, that makes sense. And it's going to roll 2 times onto itself. It's going to rotate 180 degrees. So we have this range mapping already. We know that in the input upper should be 50, which is the size of our cube. Here, the output upper, we need to change something because you can see in our range mapper operator, we have here output range, input range, user defined. Okay, let's see. We can see here some degree. Okay, that's interesting because we want to use degrees. So degrees, and you can see now it from 0 to 50 centimeter, it's going to rotate from 0 to 360, meaning one full rotation. We don't want that. If you want it to move by 50 centimeter, it should move by 90 degrees. So I'm going to change here 90 degrees, and that's it. So now when I take my connect and move it, it works. So you see, it's very easy. If you just want to have a plain old cube rolling this way, it's as simple as that. Very, very easy. Let's go back here to our coordinate to 0. Okay. If we wanted to have a more automated way, we have a problem because if I change the size of my cube, well, it's not going to work anymore. It's going to be still on the ground. So that's cool. I'm going to create a ground. That will be easier to see. Okay, so it's still my ground. Perfect. But if I move it, you can see now it's rotating too slowly. Well, of course, because we didn't update here in a range mapper. If now my cube is 25 centimeter wide, the range mapper here should be 25 centimeter. I'm not going to change that by hand every time. That's a waste of time. We can do something which is much easier, is to plug the size of the cube to this input upper. Okay, so for this, I'm going to drag the cube again inside our XPresso header. We have it here, and if I take a look here at the output, so the red value, click here, we can see here we have some object properties, and we can find the size of our cube. Okay, so the size of our cube is going to drive the input upper. Let's go, input upper, and that's it. Now it's fixed, so if I move it this way, it works. So let's keyframe that a bit. I'm going there, create a keyframe. Let's go to 90 and let's move to there. And that's it, now it works. If I want the cube to be bigger, let's do it. Let's put 75 degrees, centimeter. I can see it move 75, it works. So obviously here, it's much too short. Let's go there and give it more space.
So Drake just had a funny comment. He said, it's very funny because in the beginning you said it's very hard to do that, and now it's very easy.
Well, it depends.
Well, compared to what you would have had to do before Capsules, because this geometry axis capsule is doing the main work here, and redoing that in XPresso would be very complicated.
Yeah, there is a very good tutorial from Orestes, which was from the Maxon team, and he was using XPresso, and he had to move the anchor point, so the origin object of the cube. It was kind of complicated, and with this node, it's pretty easy. Well, it's complicated because if we want to have more control, it gets very hard very quickly. Actually, there is a few caveats. Few limitation with what I'm doing here is if you want to have your cube moving this way, then rotating on this axis, and then from another axis, you will see some very weird stuff happening. I'm not going to do that because it would be, I mean, all of a sudden it would get very complex. So I'm only going to do straight lines. But now, straight lines are boring. What's interesting is to have our cube following along the path we want. We want it to follow a curve, for example. In the video I created on the very beginning, it's going up on the ramp and then going down on the ramp. So it's the straight line, but going up, so it's a curve actually. So we're going to see another way to do it, still with the capsules, and make it work with any path, and the path is going to be a spline. Okay.
Maybe before you start, Lionel, there was one more question. Will this method work on a more elongated cube from Dimitris?
Yes.
Sorry.
If the cube here, it's always on this axis. So if I change the size of my cube, it's going to work. So that's cool. Again, it's going to work if I change a bit the size and so on. Because it's a cube, it's 6 faces, and it's just going on a straight line. if you're going to use a more complex object, we might have some problem where we might have to change the size. Is not going to work that well. We would have to calculate a bounding box so that we can deduce the size of the cube. Here it's very easy because it's a cube. Even
Yep.
what I just did is not perfect, but that would fool the eye.
Cool, thanks.
Let's go back maybe to 75. Okay, so now if I wanted to follow a spline, like a circle, it's going to be very different. We're going to use another trick. Let's see first the problem. If I'm going to create a simple circle, let's put it on the ground. I'm going to make a big circle. Maybe let's hide the plane for now. So it would be very easy. If you want to have the connect object following the spline, you just need to add a line to spline, okay? And here, the spline path will be the circle, okay? And you just need now to animate the position. And if you do that, you will see something strange happening. It kind of works again, but it doesn't. And it's easy to understand why. What you have plugged was only the X value. And the circle is going on the X and the Z value. So it's moving accordingly on the X when the circle is going this way, for example, but it's not going to do the right thing here because the motion is on the Z axis. Okay, so it's not working. So we have to do something else, and we're going to cheat a little, but you will see it's still quite easy to do, and it works. And that's the most important. Whatever works is good. So let's see the answer. Okay, so we're going to use, I'm going to keep the same setup here. The different thing is we're going to use the spline node. So if you look here on the left, you can have all your operator, and here you have the spline. I'm going to put it here, and the spline is going to sample the spline you're going to use. So here, this is the node of the spline. So it's kind of confusing because it's called spline, but you need to drag the actual spline you're going to use inside here. Then here you're going to need to take the object output and then connect it here. Okay, now you're sampling this spline, and we can use its parameter to do what we want. So our spline is going to give us what we want. So let's see, with the range mapper, we're not going to use the connect position anymore. We don't need that. I'm going to unplug it. And here with our spline, we're going to use actually the align to spline, because what's changing over time here, it's the position. So again, for simplicity, I'm going to animate this, so we will see the change. We won't have to move this every time. So let's create a position here. Let's go to 90, and I'm going to make a full rotation. Okay, so now it's moving along here. I'm going to use the tangential option, so that it's going to follow along and change its position. Okay, so now I need to get this value here inside my node XPresso. So let's move here our align to spline. And here I'm going to get the tag properties the position. So it's called position, it should be offset or something else. But it's called position, it's not already a position. Now we have a percentage. So one thing to note inside XPresso, percentage are actually number from 0 to 1. It's normalized. We can see that if we use the result node, which is very powerful. You can use it to check what's happening. So here you can see we have a result 0. If I now move through time, we can see the result. Okay, and at the end of the animation, actually you have 1. So meaning that the 100% we have here is 1. Okay, so now we know that. We can do something. If we could get the length of the spline, okay, the length in centimeter, and we multiply by this result, we will have a fraction of this length, meaning that at 1, we will have the full length of the spline. And this is going to drive our range mapper, which is going to drive the rotation of the cube. Okay, so here in our spline, I can get here the length, and we actually don't need this position. I'm going to just delete the port. Okay, now I'm going to multiply this number with this one. So the length here, I can also just create a copy to just check what's happening. So the length of our spline is 2000 and so on centimeter. And if I change the size of the circle, we can see it changing accordingly. Okay. So if I'm going now to use a math node, I'm going to do some very simple math. I'm going to multiply. So the function here will be multiply. We're going to multiply the length by this one. Okay, and with this one, we get a result. Again, I can check the result. So those are not necessary, but it's easier to read and to understand what's happening. So you see at the end of the animation, we have the same result as here. At the middle, we have half of this result, so half of the length. So that's what I want. That's the input I want to use. So now, if we want to make it work all together, this result here, we just need to connect it here to the input. And that's it. Now it's going to rotate. But we have a problem. It's kind of funny, but that's not what we want. So why does it do that? Because when we used our align to spline, it changed the axis. And actually the Z axis is pretty good. I'm going to leave it as it is. But it's now rotating on the wrong axis. So rotation B, banking, is not the one I want. So I'm going to unplug this. We're going to see our cube. So let's go to the cube here and find which rotation we need to use. Is this one? No. This one? Yes. So that's P rotation, the pitch. Let's put it here, pitch to the output. Let's see. Okay, the other way. So it's rolling the right direction, but the wrong way, or the opposite. Let's get the range mapper, and we're going to reverse the result. It's as easy as that, or I could have plugged here minus 90 degrees. So let's see, and it works. We have our rolling cube.
That's fantastic.
So what's cool with that, it's going to work with any spline you want. You can edit your spline. I can take my spline here. We can just make it editable. I'm going to open it and let's move it this way. And we will see our cube is going to follow and it's still working with the size of the cube. So if I change my cube to something smaller, it's going to work all the same.
It's fantastic. We already have the first people thanking you for that.
Yeah, so, thank you. So yeah, with XPresso, don't forget to use the result node because I'm not, I have rehearsed that again. I have stumbled a lot when creating this setup, and I'm using a lot the result to understand what's happening because I'm really dumb with math. Trust me, I'm very bad. So I look all the time at the result to understand what's happening. Okay, don't hesitate to do that because that doesn't, you can do it as much as you want. Once you're done, you just delete them for cleaner results. And now we have something that works all together. Okay, so that was the first part of the rolling cube, because now I would like to show you that we can do the same thing with nodes, the actual nodes inside Cinema 4D, and it'll be even better because we'll have something even more parametric, something we can share, something we can use more easily.
I like Antonio's comment here. Like a few people commented and are thanking you for this setup. But I really like Antonio's comment. He said, yeah, this is some black belt cinema 4D stuff. Love it.
Wow.
Thank you, Antonio.
You'll see about the nodes. It's not, again, it's not that complicated. But yeah, it takes some bit of time to get used to it. Okay, you will see that the nodes are very powerful and very promising because when they will be done, when Maxon will be done, I think we'll be able to do amazing stuff. And we can use it already for work. It's not already production ready, but for simple stuff, you can use it, no problem. I did it. For complex stuff, maybe wait a little bit. Now is a good time to learn nodes because it's still almost simple and we can do some amazing stuff already. So let's see. Let's create a new project. Okay, I'm going to close the XPresso editor and we're going to switch to the node interface. Okay, so the node inside Cinema 4D is like XPresso, but 100 times more powerful. You can do some modeling, you can do some animation, you can do almost anything you want with it already. And it's going to be even more powerful in the future. Okay, so here, what I would like to do is to replicate the first setup just to create the straight line. So the rolling cube just rolling, okay? So we can see how it works. And it's pretty easy for this part. Let's create a cube from Cinema 4D. I'm going to create the cube here. Let's put it 50 centimeter again. Okay. And I'm going to drag it here into the node interface. Okay, so it's going to be sampled and we get all these parameters. I'm not going to use half of them. Okay, so now I would like to use almost the same setup as before, meaning that I would like to have a null object which is going to drive the animation. Okay, but I'm not going to put it inside the cube. And actually, I don't need to use a cube from the, I think it'll be more interesting. I'm going to delete the cube here and here as well. So I'm just going to use a null object, okay? And to show you that nodes can create everything inside. I do need the null because this is the one I'm going to use in the viewport, okay? I want to have some axis and so on. It'll be easier to use. But I could do it without anything in the object manager. So I'm going to create the cube inside the node here. So let's create a cube and you have a mesh primitive cube. Okay, if we plug it here to the children, we can have our cube. And let's make it smaller, 50, 50, 50. Okay, now I would like to link it with this null. So when I move the null, it's going to move the cube, because here I can't move this cube. Well, I can, but I don't want to move it this way. I want to have the null to move it, to have control over it. So let's put it here. And I'm going to use the child node. So children up. Let's put it here. And the up output is going to be here for the children. I'm going to drag my null here. And the up output, so here, is going to be this one, meaning that the null is the parent of the cube. And we're going to connect all of them here. Okay, I can close here my hierarchy because it's a bit overwhelming. I don't need to see all that. And now if I just change the cube, it's going to work. Okay, perfect. Now we want to have our geometry axis. So the setup is very similar, very almost the same as with XPresso. We're going to use our geometry axis. So it's exactly the same one as before. Okay, but this is the node, the real node, not the capsule. Okay, and if we take a look here, we have a geometry in, geometry out. Okay, so I want to put it there because we want to work on the cube. The cube here, we can see we have a geometry node, a geometry output. So I need to plug this one here. Okay, then we have a geometry axis, geometry out. The geometry out can be connected here because this is a op. You can see the difference between the op and the simple noodle, I would call it, because the op is going to pack a lot of information. It's going to pack the geometry, it's going to pack the matrix, meaning the position of the object, and so on. And here it's only the geometry, meaning the points, edges, and faces of the object. Okay, so it's not enough here. Here it's expecting a full op. So for this, we have the geo op. This one, we're using it all the time. So you'll get used to it very quickly because you need it to convert your geometry to a op here. Op output, we can plug here. Okay, so back to square one. But we have our geometry axis. So now we can do this. And you can see here we are sliding along its axis. And again, now it's flat on the ground. Okay, and if I take my null haven't moved from place. So it's still here. Okay, now to rotate the cube, we're going to use something else, which is the transform element. So that's actually the main problem with geometry node. We have a lot of nodes. I mean, really a lot of nodes. So they're all in category you can find, but it takes some while to get used to the category, to what you need to find, and so on. But after a while, you know where to look. And what I'm looking for here is a transform element, which is again a node very often used, transform element. Okay, again, we have a geometry in and geometry out, perfect. So let's plug it here. We want it to work before the geometry axis. Let's plug it here, okay. Still nothing, but if I take now my transform element and I find here the transform R, you can see we have some parameter transformation. If I change here, you can see we have our rotation again, exactly like we want. Okay, so if I wanted to move it on the here on the red axis, again, I need to find, and it's going to be this one. Okay, so now we have found what we need to drive. We want to drive this one with the position on X of this null object. Okay. As soon as you know what is going to the driver and what is going to be driven, you have solved the problem. Well, kind of. So I'm going to take my transform. So now what I need to do is to expose this parameter, and it's here. So you don't find it here. You need to right click, add input. I'm going to take here the transform. So here it is. Okay, transform, perfect. Now I need to put a node to control that. This is here a matrix. You can see here the type of node, matrix. Matrix is the position of the node, but also the scale, also the rotation. And we do have a node we can use to compose a matrix. Compose matrix. Okay, let's put it here. And we can find here the result. We have a translation, scale, and rotation. This is the rotation I want to use. And you can see it's already plugged, already working. But now I want the rotation of the X, of the Z axis only. So we can use here the vector compose vector 3D. Now we have 3 values driving our object. So this is the Z value, Z. This is what we want to use. Okay, so we're getting close because now we want to expose the transform of our null object. Okay, so if I take my null object, let's open it. We can see here we have a matrix. Okay, we have a matrix input output. Here again, what I'm interested after is the matrix. So I'm going to do the opposite of that. I want to have my matrix. I want to decompose the matrix. Decompose matrix. Here we were composing the matrix. The other way is to decompose. So the matrix of the object, meaning the position of the object here. Now we have a translation. Okay, so now we need to find the opposite of this node. So it's called, well, it's called split vector. It should be called something else, but it's split vector. So split vector, you can see here we have the dotted color is going to give us the kind of input you need. So it's easy, blue goes to blue, purple goes to purple, white goes to white, and so on. So rotation, actually this is the translation because we want to use a translation. And we have our X value. So we just need to connect the X value here to the Z position, Z rotation of the compose vector. So we do that. And we're doing exactly the same thing as with XPresso. It's just different, okay? And if I would use Houdini or Blender, I would do the same thing with nodes very similar because it's all math behind that. You just need to find the right node with the right name and so on. So now everything is plugged and we're going to have the same problem as before. Okay, but you can see it's working. So let's go back here. I'm going to animate our null object. Not too much, let's go there. Okay, so now we have an animation and we have again the same problem as before, meaning that we need to use here a range mapper. So we do have the exact same range mapper. Range mapper, I'm going to plug it directly here. Perfect. And we just need to figure out here about the input max. So it's easier now because we know how to do it thanks to XPresso. The input max was the size of the cube. Okay, so the size of the cube is in there, but I'm going to do something different so that we have better control. That's something different from XPresso, which is going to be better. I'm going to use here a node which is the value node. Okay, the value node is just a number you're going to punch in. So I'm going to put 50, for example, and this is going to be the size of our cube. Okay, so I'm going to plug it on the cube itself. Let's go there. And here I will find the object parameter size. Okay, so now I'm controlling the size of my cube. And that's perfect because I know this number should be here in the input max of my range mapper. Again, same thing as XPresso. We used it as input max. And here, the output max, well, we don't have the degrees we had in the range mapper. And something you should know, if I unplug this one and we take a look at the Z, if I move it here, you can see this is not degrees. Here, if I go to 3.14, we have a full rotation, actually 180 rotation. So this is some radian, okay? Radian unit, not degrees. Once you know that, it's pretty easy because we know now that 90 degrees is half of pi. I just need to plug it here. And the output max here is going to be half of pi. So 314 divided by 2. And that's it. Now, if we take a look, it's working. So I know it looks complicated because I was wondering in my head, well, it sounds complicated, but we did the same thing as XPresso. Okay, it just looks different and everything is inside the node here. So what's cool with this is everything can be plugged to anywhere. So here, this value is my size of my cube. Again, I can change it to 25 degrees, 25 centimeter, and it's going to work all the same. I can put it to 100 centimeter, and it works also. And ready to achieve this, because I repeat, I'm very bad at math, I just repeated, I used XPresso to practice and to figure out what to do with the node system inside Cinema 4D. And so this way I could do it. So, well, I'm a bit, that's too bad. I can see I have only 5 minutes and I want to show you how to make it work with the spline now. So I guess I'm going to overflow a little bit. Maybe you have question?
Not for now. I think everything is too easy that nobody has got questions. No, it's pretty impressive, and yeah, some people were writing, well, it's getting intense now. Yeah, just go on.
Okay.
No questions for now.
Because now it's now it's getting interesting, and now we can see how it's going to be more powerful than XPresso. Because really, trust me, at the very beginning with nodes, I was telling myself, but I don't know what is it for. Because with XPresso, it's easier and faster. Well, yes, up to a point. And then if you get to some complex setup, if you want really to have some parametric setup, it's going to be complicated. More complicated with XPresso. And also, you will see at the end, I'm going to make an asset, meaning that I'm going to pack all that into a simple file that I can share with anyone, and I can reuse anytime I want. And that's a real power of Node, something we cannot do with XPresso. Okay, so let's see how we can use now some Spline and to do the same thing as XPresso. And again, it's the same thing. It's just different. Okay, so let's create first a spline. I'm going to create spline here from the object manager. I'm going to create again a circle. Let's make it bigger. Okay. And well, same thing, same drill. I need to sample this spline in order to be able to do something with it. So we do have a node for that. Sample classic spline. Perfect. I'm going to put it here. And this sample classic spline asks for a spline. So this is going to be a circle. Okay, now we need to recreate the align to spline node. Okay, so for this one, instead of messing up all this, I'm going to kind of recreate everything. Let's take our cube. I'm going to duplicate it. Also, I'm going to take my root. I'm going to unplug all this node. So now this node is not doing anything. I'm just going to put it aside like that. Okay. So this is the output. If you need to see something, it must be inside this node. So I'm going to plug my element. My cube is here. Okay, perfect. Now my sample classic spline. We have a sample position. Okay, and I'm going to use it to compose a matrix. So again, always the same node. We don't use that many nodes. It's always the same compose matrix, decompose matrix, and so on and so on. And you plug everything together. So we have a sample position. It's going to move the translation, meaning the position. Okay, and we have here a sample tangent, which is going to drive the rotation. So we're going to use a node, which is the alignment. Again, I'm recreating the align to spline expression inside the node. So here we need the alignment. I'm going to put it here. And the sample tangent is going to be plugged to the orientation. Okay, those two are going to be plugged into another kind of matrix, the transform matrices. This is to combine two matrices together. Okay, you have matrix 1, matrix 2. So one is for the translation. The other one is for the rotation.
And matrix 1 was the better one, just to.
Obviously, yes. And then with our matrix, we have the position. We need to input it here somewhere. So it's going to be a matrix up. There we are. Okay. So this is going to the matrix up, the result. And actually, our cube is going to be here in the input. Now, if we plug everything together, we have our cube on our spline. And here on the sample classic spline, we have our position. Okay, so that was only to recreate the align to spline because we want to be pure node. So yeah, I'm switching just for clarity. On my second screen, I have some reminder. Okay, so I don't mess anything up, but I do cheat a little because I have that under my eyes. So now we want to combine this setup with this one. Okay, and what's going to make the cube roll into itself? It's those three nodes, those three. Okay, so I'm going to control and move them up. Okay, so that's what's going to make them to make the cube roll onto itself. So I'm going to plug our cube here to the transform element. So we have a geometry here. I'm going to plug the geometry in, and then it's going to be on the geometry axis, and then the geometry up. Okay, the geometry up is going to another to our matrix up. Okay, so I'm just going to here this one I'm going to unplug it and plug this one instead. And we do have, again, our cube. The difference here is our cube is now aligned thanks to this. And now we have access here to the transform, which can make rotate the cube. So now we need to, again, decompose this matrix and find a way to make it work with all this. Okay, so let's go. I'm going now to compose a matrix. Compose matrix goes there. Now we need a compose vector 3D is going on the rotation. Okay, so now it's going to be on X this time. And this is the value I want to drive. Okay, now if we think about our last setup, we had on our sample, our spline node, we had a length. We do have this one here also. So if I add input, because you have hidden input, you can find here our length. So this is the length of our spline. Now I need to find the way to add everything all together. So we have, I know already here on the x-axis, so this is the one I'm going to drive, I need a range mapper. So let's put it already. And the range mapper is going to drive the x. Okay, now we need to find the value which is going to drive this one. So the value here, I mean, the value here should also drive the value here on the offset or our object. Okay, so we're going to use a value. This value is going to drive here on the sample classic spline the offset. Yes, the offset. Yeah, it's called position with XPresso. So that's confusing. All right, so the result here is going to drive the offset. So meaning now with this one, I can drive the position of our object. Perfect. And now if I use this result here to the value, it's going to make it rotate. Okay, so almost, because you can see it's rotating, but very slowly. But it's working. So I just need to find the right number. Okay, and here's the trick with the length. We want to divide the length of the spline by the size of the cube. Okay, and this is going to give us the value we'll be able to put it here in the input max. So let's create a slider for the size, which is going to be a value. This one, I can rename it. It's going to be progress. Okay, progress along the spline. This is going to be the size of the cube. I'm going to plug it here on our cube object size. Let's make it 50 centimeter, maybe 100 centimeter. So it will be bigger. Okay, so now this size, I want it to divide here the length. Okay, so I'm going to use a math arithmetic. So a math node, it's called arithmetic, not math. And we're going to put it here. So the length is going to be divided by the size of the cube. Okay, and with this result, we can have now value, which is going to be better for us to use. If I go here in the input max. So let's plug it here. And now we just need to find the right value here for the output max. So let's take a look here. I'm going the progress. We need to drive it again. Let's go to 1. So we have a full circle. Okay. And our output max, well, I need to take a look at my reminder here because, yeah, it's getting a bit tricky. Yes, of course, this is a mistake. The input max shouldn't be there. The input max here is the size of the cube. And then this is the output max we're going to use here with this result. So I'm going to put it here. And if I put it here on the output max, we're almost there. Okay, yeah, it's better. We just need to find the right multiplication on this node. So let me organize that a little bit. It's going to be arithmetic again. Let's put it here. It's going to be multiply and here it's going to be 3. So 314 pi divided by 2. And that should do it. No. I'm very close, I'm sorry. There's something wrong with it. Maybe because we're already out of time, I'm going to load the final file. I'm very, very, very close. This is very frustrating because I'm so close. This is the divide.
Yeah, but it needs some sort. It needs to be some sort of multiplication, doesn't it? Because it does rotate.
Yeah, I'm going to, yes, obviously, and I'm going to load the final file because I mean we're already out of time. I'm not going to fumble. So let's get our final result. So it's here. It's rolling cube.
Yeah, can it just be that it's a multiplication of like with 100 because of the percentage versus
we're going to see. So
the actual distance.
This is the final the final one. So now it works. It's the same. So let's see here. We have our length. And here I'm just adding here the float. All right, we didn't have to divide actually. I was, yeah, I make a confusion with the XPresso. With XPresso, we had to divide the result, and here we need to add the size of our cube to this one, to the length, and then we have the multiply, and this is, yes, the inverse of half of pi, and then goes to the output max. Yeah,
right.
so
Solved it.
yeah, it's not easy. it's definitely not very easy, but it works now. We have our complete setup. So just to finish, because what's the use of doing something that difficult? Well, what's interesting is to make an asset out of it. Again, maybe I'm not going to show it right now because we don't have time, but you can make an asset of this. So let's just show in another file. So what I did.
Well, I think you can show it. I mean, making it an asset would take like 5 more minutes or so.
Yeah, let's go. I just need to make a few more parameters, so it's going to be nicer. So we have our size. Okay, so this is the progress of the cube. We'll make it very simple. We have the progress of the cube, which is well, how much it goes through the spline, along the spline. We have the size of the cube. Okay, I want to have control of all of these two. So we're going to have control of that. And also I want to have control of our sample here, the object. Okay, so those are all the elements I want. So I'm going to group all of this. Let's make them convert asset to group. No, not this one, sorry. Convert to asset. And let's call it rolling cube v2, because I already done some category. Let's put it inside node geometry generator. Okay. Now, if we go there, convert asset to group, this is not the right way. I forgot something, but never mind. So if we go back here, we can have the progress. I'm going to propagate the port by putting it here. Propagate port. This is going to be the progress. Here, I'm going to reveal the input of my size. Let's put it here, propagate port. This is going to be the size. And last but not least, we have the object, propagate port. Okay, now if we go back one step, we have already everything here. We have the progress, we have the size of our object, and the type of spline we can use. And this one, I'm going to convert to asset. So this is not the right way. I messed up something else here. But I'm going to just create another node. So it's going to be rolling cube on spline v3. And let's put it in the nodes. Let's put it on the geometry generator. Okay. Okay, now it's been converted to a node. So now I can create a new scene. So this is a brand new scene. Let's see our asset browser. And in geometry generator, we can see the asset I've just created, this one. So I'm going to put it here. We have all the option we need to use. I'm going to output here directly. Okay. And here it needs a spline to work. So let's create a helix. And just going to change a bit the size like that. Okay, if I go back to my node, to my asset, I can put my helix. And now I have my cube rolling on my spline. And this is an asset I can use in any scene I want. I don't need to merge any project or whatever.
Yeah, and that's exactly like the advantage of or the key thing about using scene nodes. That's what you can do with a system. You can like create really complicated setups, or also ask other people to create very complicated setups, like Lionel,
Yes,
for example.
that's
And they will
the
do it for you, export it as an asset, and you can then use it in your scene. And yeah, it will just work if it's done correctly. And then you can like distribute it with your colleagues and friends and family,
exactly.
whoever.
Just what you have to do at the end is that you take here, right click, export latest version. It's going to create a zip file. Then you're going to give this zip file to anyone you want. And to import it, you need to go to here inside. It's create import assets with the zip you just obtain.
Exactly. And then you can even add this to your own custom database. I also created a quick tip on databases and assets. Maybe I just search for the link so I can share it in the chat. Give me a second. I interrupted you anyways, Lionel. So.
No, I'm done.
Sorry.
I'm done and exhausted. I'm so sorry to have fumble at the very end, but maybe if you rewatch, I'm going to rewatch to find where I know what I did. I just confused XPresso with notes. I didn't have to divide the result. Well, I know now the mistake, but 90% of it was good. So I'm happy with
Well,
that.
there have been comments about how chill you remain when you fumble. I think it's awesome. Just like, oh, I'll just kind of,
I was
mosey
panicking
along.
inside. And yeah, so you will have access to this node, to this asset I'm going to share, and the final assets have more control over the size of the cube, the chamfer, and some more stuff. It's still a pretty simple node, pretty simple asset, but still it's cool. Just a final note, Chris Schmidt have created very cool assets that already available for any customer. Which is the grid creator. You should check it out. It just been released, I think, just yesterday or the day before, and it's a very good example of what nodes are going to be capable of in the future. You don't need to master the node to use them, thanks to those assets. And I'm
Absolutely.
done. And late. Sorry.
No worries. So yeah, if you want to use that asset, you can just type in grid spline into the search field in the asset browser, and there you will find it. You can create really cool grids then, and yeah, create those splines. Chris Schmidt also created a nice tutorial about that. Of course he does, or he did, and it's a really cool tool to create all sorts of FUI elements and so on. So really great. You can also throw it into a MoSpline and then affect it using effectors and so on. So it's a great asset. Cool. All right. So I'm going to grab the screen back from you. Here we go. And now you should see my screen. Can you see my screen?
Yes.
Yes. Okay. Interestingly enough, now, yeah,
There
good.
it is. I was
Yeah.
gonna say, I was just hoping it was a leg.
Yeah, it just told me that it paused the broadcast, and now it says it's broadcasting again. So yeah, thanks for being here, guys. First of all, of course, Lionel and Dustin, but also everyone else, our audience. Thank you very much for being here. Of course, this session has been recorded, and you will be able to watch the recording later on the Maxon Training Team YouTube channel that you can see here. So just search for Maxon Training Team YouTube channel. And on the Maxon events page, maxon.net/events, you can find all of the upcoming events listed. So the next one is going to be, let's see, yeah, it's going to be the Ask the Trainer session that Thanasis and I, or Noseman and I, are going to have on Thursday, where we are going to talk about rigging fundamentals. And as I mentioned earlier, we have this Maxon certification site, like maxon.net/certification, where you can take a few tests, like this free elementary knowledge test, which is like a multiple choice test. But we also have this main certification test for pro users or advanced users, and a certification topics list that is, well, pretty complete. It's pretty long. And the plan for Ask the Trainer is that Noseman and I pick a topic, and we're gonna discuss it and show setups and so on. And we're gonna go a little bit deeper than usual. You can also prepare questions. As I said, the next topic is rigging fundamentals. So if you have any rigging related questions, then please prepare them. You can also send them to training@maxon.net in advance. Or you just show up and ask them there. We have prepared a few things, and but we can also answer questions. Cool. Again, thanks for being here. We want to give you a free t-shirt. Hey, in the handout section in the GoToWebinar interface, you will find a PDF document with a link to the Maxon merch store and a coupon code that you have to type in once you enter the shop, and then you will be forwarded to this site here. And here you can pick a t-shirt, one t-shirt, and you can order it for free. You will only have to pay for the shipping. All right. Again, thanks a lot, everyone. Thanks for being here. Thanks, Lionel. Thanks, Dustin.
Thank you.
That was a great one, a pretty intense one, but it's also really great to see what C nodes are already capable of. And I'm looking very much forward to what our users are going to create with this, and yeah, quite excited. So have a good rest of the day, everyone, and see you next time, hopefully on Thursday.
Bye-bye.
Bye,
everyone.
everyone.